starting with the number 17 problem. The problem says the number 3572404 is divisible by, there are options, so options are given 7 or 5 or 11 or 9. So we may try from any of the side, so but individually we will try with all the numbers. So better to try to eliminate seeing the numbers and the digit that is given to decide whether this digit is divisible by all these numbers. So I know each of this number. The number that I will attack first is 5. For 5, if it is a divisor for any number, then you have to consider on the last digit. The last digit must be 0 or 5. So neither of the condition is satisfied. So I can eliminate this number and need not to calculate. Now if I consider 7 and 9, for this case both the cases I have to add the digits. Only thing is that for 7 I have to add up to this, and for 9 I have to add up to this. So let me try adding this number. 3 plus 5 8, 7 15, 17 21 25. So for 9 it is 25. If I divide with 9 it won't divide it, so I can eliminate 9 also. Let 7, so I have to take back 4, so it will be 21. 25 minus 4, 21. Now I have to calculate 21 minus twice of that last digit, divide by 7, whether it is divisible. 21 minus 8, that is 13 by 7, it is not divisible, so 7 gone. Now remaining is 11. So for 11 we know we have to choose the number places where for 11 I have to decide the from right hand side, add odd places minus even places, and if it is divisible by 11 or 0, then it is a divisible by 11. Now try this. Odd places is this and this. 4 4 8, 7 15, 18 minus 0 plus 2 plus 5 7. Now let's see, 18 minus 17 is 11, so it is divisible. So I got correct. So 11 is your answer. Okay. Now come to 18. Eighteen says the value seven 8 6 8 multiplied by 7 8 9 6 3 multiplied by is the multiplication of those digits. You have to decide whether it will be odd. Second option is even. Third option is both. Fourth option is neither. So I don't think any number simultaneously can be both odd or even or opposite of that. So this I can eliminate straight away. No number you will find will match the condition of odd or even both. Cannot be. So this option. So now I have to decide whether odd or even. So one concept is very clear and very easy to understand. If I multiply even with any odd will give you even. Okay, and if I multiply any even with any even, then also I will find even. There is no ambiguity in that. And the least of the even value, that is 2, if I multiply with any other thing, that will also a even number. So from that concept, without calculating further, or without which people may start calculating or multiplying this number, and that after that they can decide. But without calculating anything, if I consider on the last digits, these are containing even numbers. So if anything multiplied with this, whether it is even or odd, if at least one which is even, that means last place is even, then the number would automatically be even. So if I multiply any number, the result must be even only. So there is no ambiguity or thought may come second. So any even multiplied with any kind of number, it will give you even. So this result will be even. So need not to calculate it. Okay. Next comes number 19. So it says the prime triplet. You have to find the prime triplet out of the options given 4, 5, 6, 13, 17, 19 and 11, this, then 6, 7, 11. So one thing is that first term we have to catch it. The number must be prime. So all the set of number which is given must be prime. All three are to be prime. So that is the first. Now then come triplet. But one thing you have to remember, this is not same as the Pythagorean triplet. I have taught you Pythagorean triplet. There the numbers must be related like that. M square minus 1 and M square plus 1. These are Pythagorean triplet where this square plus this square must be equal to this square. That I proved. So this must be related this way. So, but this is not the Pythagorean triplet. Don't confuse with the Pythagorean triplet. It is something else. So first, what I have to see, the set of numbers that is given to decide whether it is a prime triplet. I have to see whether all three numbers, all the numbers of the set is a prime. So I can eliminate that number, that set itself. So out of this is not all prime. This having prime. So first selection out. This also not prime. I can eliminate. This is also not prime. The only option I having this one. So I need not to calculate it. If it is an optional one, so I can straightforward I can say this, because any other numbers are not all sets. All the numbers of the sets is not all prime. So from that I can eliminate 3. So this definitely to be answer. But concept was I need to know the prime triplet has to be related something like that, or there are only two possibilities for prime triplet. So that means any number will, this 2, 3 consecutive prime number you can say, have to, the difference between the first two may be 2 and the extreme one always to be 6. This is standard for the first number and the last number. The difference would be 6. In between there is a variation. Some might be with 2, might be plus 6. So if I see this 13 plus how much 4. So this is following this. So n is equal to 13 if I say. So n plus 4, that gives you 17, and n plus 6 will give you 19. So 13, 16, 17, 19 is the correct answer for this case. So prime triplet, you must remember these are the conditions for that. Okay. Now next comes here you have to find the total number of this is 20 number. You have to find total number of factors of 51. So this is not a big thing. Only thing is that you have to prime factorize this one. So 51, as this is a small number, I can say it has to be 51 into 1, 3 into 17, and MC there should not be any other combination because these both are prime number and these are the number itself, and the 1 is always true for any number. So apart from this, any combination is not possible because these are prime numbers. So the total number of factors here it is 2, it is 2. So you just remember, for any factorization the number of factor must be multiple of 2 only. Okay, so that means the factors for any number would be even always. Exception is that where the number is a perfect square. This is the exception. How? Let's say I am taking 9. So 9, 1 into 9 will be are two factors, then 3 into 3 is another factor, and if you reverse it. But in this case, you see the things are same here. That means you cannot count 2 here. It has to be counted 1. Here it is 2. So that means for square, for the perfect square, the number of factors should be odd. Okay. For any other case, it has to be even. So that is a concept. You may face some problem somewhere where this concept may be used. So this is for now. In the next class, I will start from number 21. Okay.